Okay, so for today, 9.7 day 2, we're looking at radians. Okay, radians would be the length of an arc associated with the given central angle in a circle with a radius of 1 unit. Blah, 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 lots of words. Basically is what that's saying. To break that down into individual concepts, a radian is just another way to measure an angle. Okay? So let's talk, before I go into that, let's talk in a circle. Okay, in a circle, we would say that if I measured how big is a circle in degrees, we'd say 360 degrees. Well, in the military, if you look at a military compass, it's not 360 degrees. We measure it in 3,600 mils. That's what it's called. So a full circle in the military is 3,600 mils. In degrees, it'd be 360 degrees. Well, a radian is a new way of measuring a circle. We talk about it as the central angle in a circle with a radius unit of 1. So if this circle specifically has a radius of 1 unit, could be miles, could be meters, could be feet, doesn't matter, 1, then we can talk about the amount of angles that it forms up in as a matter of radians. Instead of degrees, we talk about them as radians. And so if you wanted to convert from degrees into a radian measure, we'd use the following relationship. So before we talk about radians, let's talk about degrees to mils. For the military example, if I have 360 degrees is a full circle in degrees, then what would that be a full circle in mils? 3,600 degrees. If I had 180 degrees in mils, we would times that by 10, and we'd end up with 1,800 mils. Not degrees. Let me erase this degree symbol. That's wrong. Oh, I can't even do it like that. I got to do this. Silliness. Okay. So this would be in mils. So our conversion, let's say it's 90. We would just have to times it by 10, and we would end up in mils with 900 mils. We went from degrees to mils by timesing by 10. So if I get rid of all these marks, and now we talk about how to go from degrees to radians. The first thing I want you to understand is that a full circle in degrees, we know it's 360 degrees. Well, a full circle in radians is 2 pi. Now, a half circle in degrees, we know that's 180, that's a semicircle. Well, what would a half circle in radians be? We just got to cut this in half. It would be just pi. And a quarter circle would be 90 degrees. And a quarter circle over here, I'm going to draw it to be a half circle. This would be a quarter circle. And it would just be pi over 2. So this is kind of some common radian measures that you're going to see. A full circle is 2 pi. A half circle is just pi. And a quarter circle would be pi halves. So it doesn't really matter what degree I'm given. I can find the radian measure by following this relationship. So let's say the degree measure. Let's say I tell you that the measure is 45 degrees. I'm going to multiply that by 2 pi over 360. Well, we know that we multiply the top and then divide down. So if I multiply the tops, I'm going to end up with 90 pi over 360. Now I can reduce this to be 9 over 36. And I can reduce this to be 3 over 12. And I can reduce this to be 1 over 4. So don't forget your pi's on top. 3 pi, 1 pi. So my final answer is going to be 1, or look, we can even just get rid of the 1, just write pi over 4. That is the radian measure represents 45 degrees. Okay. So I hope that example was helpful. If we want to convert from degrees to radians, we're going to use that relationship. to convert back, let's say I give you a radian measure, and I want you to tell me how much it is in degrees. Then we're going to follow this relationship. These are two equations that you should definitely know how to use for the test. So let's say I give you a radian measure of pi. And I say, okay, the radian measure is pi. How big is it in degrees? We times that by 360 over 2 pi. Well, we know that we multiply the tops, so I end up with 360 pi over 2 pi. Well, the pi's can cancel out, and 360 divided by 2 is 180. So now I went from radians into degrees. And back from our previous discussion, we know that pi is, in fact, a half a circle, 180 degrees. So hopefully these formulas will be fairly simple. I'll tell you what it is in radians, you tell me what it is in degrees. I tell you what it is in degrees, and you tell me what it is in radians. Okay, so this is going to help with problems 20 to 35 from the worksheet. So an example to help prepare you for that is right here. So find the arc length for an arc of a 150 degree circle with a radius of 1 unit. Okay. The reason why this becomes important is because we're going to see that that's the same formula. Anyways, first step is we use the arc length formula because we're looking for an arc length. We plug in our radius of 1. We reduce down the fraction, and all of this is just simplified. 150 over 360 becomes 15 over 36. The 15 over 36 becomes 5 over 12. The 2 and the 12 cross out, and I get 5 over 6 pi. So this is the arc length for 150 degrees, also known as the radian measure. Let's talk here about the homework, problems 20 through 35. They're on the back side of the page. They're all right here. We're going to find the arc length for a circle with radius of 1 and with the given angle degree. So right here for number 20, it's 30 degrees. I'm going to use my radian measure. 30 degrees times 2 pi over 360. That's for converting from degrees to radians. This is asking us to find the arc length. Well, since these are all central angles, we know that all the arc lengths are the same as the degree measures. Okay, now I want you to notice that this angle right here is not 45 degrees. We're building off of from here. So this is 30 degrees. This is 45 degrees. This is 60 degrees. This is 90. This is 180 degrees. This is 360 degrees. We always start from the 0, from the x-axis right here. And we build in this direction. That's why the arrows are all pointing that way. Okay. So if I'm using the arc length formula, the arc length formula is from our cheat sheet. It's right here. The length of AB equals 2 pi r of the arc of AB over 360. But our radius right here is just 1 for all of these problems that we're going to work on. Uh-oh. Here we go. So in our formula, we say the length, arc length right here, is equal to 2 pi r, but r isn't there. There is no r. We don't have to worry about that. Times by 30 over 360. So we reduce the fraction down, and we're left with 3 over 36. This gives us 1 over 12. Okay? And now we're going to multiply that by 2 pi. So we know we times the tops, so I end up with 2 pi over 12. 2 over 12 gives me 1 pi over 6. So my final answer for the arc length of this value is pi over 6. Problem 20 done. Let's do another example so we can make sure we got it down right. So right here we got 45. I'm looking for the length. I go to my cheat sheet and I realize that that's equal to 2 pi r times the arc length, or the measure of the arc, which is 45 degrees, over 360. Well, this can reduce down to be 1/8. So now I take that and I times it by 2 pi. Remember the r is just 1, so it goes away. I times the top to get 2 pi over 8. Reduce this down to be pi fourths. So this value right here is pi fourths. We can keep going on. I want you to do each and every one of them. I know it seems like a lot, but you'll get the rhythm. You'll see the pattern of why these are so valuable. Okay. There's your homework. Work on those. Let's see here, 9.7. This is a pretty funny one. I love these. Let's eat grandma, or let's eat grandma. Punctuation saves lives. This top one means we're going to physically ingest grandma. This one with the comma means let's eat, and they're talking to grandma. It's kind of funny. I enjoyed it. Summarize what you learned. Here's a look at the calendar. We're going to finish up 9/7 Friday, test on Monday after a good long review, and then we'll start into chapter 6. All right, there you go.